Hello students, please welcome to the class. In today's session, we are going to discuss about the first chapter in the second PUC, that is electric charges and the fields, the numerical problems related to class discussion. Okay. Today in the last before class, we have completed the whole syllabus of the first PUC. PUC. I hope you have understood each and every point. Please make sure that all the problems will get practiced and all the problems knowledge has acquired to you, so that it can be applied for the second PUC topics also. Is it right or not? So let us start. Let us start solving the numerical problems related to electric charges and fields. So before that, my request is, I have already given the synopsis and important points and important formulas related to this particular chapter, electric charges and fields, in the last session. First, you please go through the video and practice the formulas. Okay, as many times as possible, because whenever we come to second PUC, it plays a very important role. From every chapter, the weightage will be very more for your CET entrance examination. Okay. So let us see how can we apply those formulas and how can we solve the questions one by one. Okay. Let us see the first question what they have given to us. An electric dipole is placed at an angle of 30 degree with an electric field intensity 2 into 10 to the power of 5 Newton per coulomb here. So see here, theta is equals to 30 degree. Electric field is equals to 2 into 10 to the power of 5 Newton per coulomb. It experiences a torque equal to 4 Newton meter. Torque is also given 4 Newton meter. The charge on the dipole, we have to calculate what is the charge on the dipole. Here. So if the dipole length is 2 centimeter, usually dipole length is measured by 2a. 2a is equals to 2 centimeter, that is nothing but 2 into 10 to the power of minus 2 meter. So how can we solve this problem here? See here, we know that torque is equals to P into E into sine theta. Therefore, P is nothing but Q into 2A into E into sine theta. Just substitute all the values, definitely you'll get the answer. What is the torque? Torque is nothing but 4 Newton is equals to, what is the Q? We don't know that. Q into, what is the length of the dipole they have given? 2 into 10 to the power of minus 2 into electric field. Electric field is equals to 2 into 10 to the power of 5. 2 into 10 to the power of 5 into sine 30 degree. Is it right? So 4 is equals to Q into, we can say sine 30 is 1 by 2 and 2 will get cancelled here. So 2 into 10 to the power of 3 we will get it. Therefore, Q is equals to 4 by 2 into 10 to the power of minus 3. It becomes, so we can say Q is equals to 2 millicoulomb. Is it right or not? Hence, we can select option D as a answer. So if you believe it or not, this type of problems will be asked frequently in every year in our CET. So please don't neglect the basic formulas and basic applications here. So let us move on to the next question. What they are saying to us, a charge 20 microcoulomb. What is the charge here? It is 20 microcoulomb plus 20 is placed at the center of a hemisphere. The center of hemisphere of radius, what is it? 10 centimeter as shown in the figure. They are asking what is electric flux through the hemisphere is. So see here, whenever we want to calculate the electric flux, we need what is the Gaussian surface. How the Gaussian surface? Gaussian surface is a closed surface. Gaussian surface is a closed surface. Therefore, let us imagine a closed surface for this. Therefore, by Gauss law, we can say that the total flux will become equals to Q by epsilon naught, which is nothing but the flux through two surfaces, the two faces. Therefore, I want to know what is the flux through hemisphere. Okay. So what can you say here? It is always equals to Q by 2 epsilon naught. What is the Q value? This is 2 in 20 into 10 to the power of minus 6 divided by 2 into what is epsilon naught value 8.854 into 10 to the power of minus 12. Is it right or not? So 2 here. Approximately you can say that 10 divided by 8.854 can be taken as 9 ma. It is equal into 10 to the power of minus 6 plus 12. If you do simplification, you get 1.1 into 10 to the power of plus 6, we will get it 1.1 into 10 power plus 6 means we can go with approximately option B. Is it right or not? Which is nothing but 11 into 10 to the power of 5. 11 into 10 to the power of 5. So you can go nearly with option B. With option B. I hope you understood this now. In order to apply the Gauss law, we must require the closed surface. Closed surface. Okay. So similarly, let us see the next question. What they have given to you. In a field-free region, two electrons are released to move on a line towards each other. Let us say this is one electron and another one is this is another electron. Each other with velocities of 10 power 6 meter per second. The distance of their closest approach move only each other. That means, see here, one electron is moving with velocity v and the other electron is also moving with velocity v. Since electrons are negatively charged particles, because of the like charges, they will repel each other at certain distance, okay. And they are asking what is the minimum distance. What is the minimum distance? We call it as distance of closest approach. Distance of closest approach. So see here, what is the condition now? What is the definition of distance of closest approach? The distance at which the kinetic energy of this system of these electrons will get converted into potential energy. Therefore, we can say that half mv square plus half mv square must be equals to 1 by 4 pi epsilon naught into q1 q2 divided by q1 q2 is e into e r square divided by r naught. Is it clear? So just to find out, we'll get what is the value of r naught. R naught becomes equals to E square divided by 4 pi epsilon naught into mv square. We'll get it because half mv square is nothing but mv square. Velocity is given. Charge, we know what is electronic charge 1.6 into 10 to the power of minus 19 coulomb. So just substitute all the values and simplify. You will get the answer 9 into 10 to the power of 9. Illi 1.6 into 1.6 into 10 to the power of minus 38. You will get it divided by m. M is nothing but 9.1 into 10 to the power of minus 31 kg. Okay, into v square. V square is 10 to the power of 6 into 10 to the power of 6, which is nothing but 10 power 12. 10 power 12. So just simplify. You will get it here. So in the numerator, you will get 2.56 into 10 to the power of, we can say it is a minus 29 here, minus 29 plus 31 minus 12. So if you simplify this value, 2.56 into 10 to the power of minus 29 minus 12, it becomes equals to, usually it becomes how much here, minus 41, it becomes minus 41. So you'll get 10 to the power of minus 10, 10 to the power of minus 10. So 2.56 into 10 to the power of minus 10, in the sense we can select option C as a right answer. Option C as right answer. I hope you understood the definition of this closest approach here, distance of closest approach. So like that, we have to move on to the next question. What they are saying to us: an electric dipole consists of two opposite charges each. What is the charge on the dipole? They have given us 0.05 microcoulomb, which is nothing but 0.05 into 10 to the power of minus 6 coulomb, separated by a, what is the distance they have given? 30 millimeter. 30 millimeter. So which is nothing but 30 into 10 power minus 3 meter. So the dipole is placed in a uniform external electric field. E is equals to 10 to the power of 7 Newton per coulomb. The maximum torque they are asking here. Maximum torque we have to calculate. So see here, how can you simplify We know that the torque is equals to PE into sine theta. For maximum, sine theta must become equals to 1. Therefore, the maximum torque will become equals to P into E. P P can be written as Q into 2A into capital E. Therefore, we can say maximum torque is equals to, what is the Q value here? 0.05 into 10 to the power of minus 6 into, what is the length of the dipole? Length of the dipole is 30 into 10 power minus 3 here. 30 into 10 power minus 3 into, what is the electric field? 10 to the power of 7. 10 to the power of 7. So just do calculation. Definitely you'll get it here. So we can say that 5 into 30, 150 into 10 to the power of, here you will get 10 to the power of minus 8 here, minus 8 minus 3 plus 7. So do calculation here, 150 into 10 to the power of, we can say minus 4. Is it right, minus 4 Newton meter, minus 4 Newton meter. So 150 into 10 power minus 4, it is not there, but we can say it is 15 into 10 to the power of minus 3 Newton meter. 15 into 10 power minus 3 Newton meter. Hence we can select option C as a right answer. I hope you got the answer. Very simple formula. So we have to remember so that we can easily calculate the answers. Let us move on to the next question. What they are saying to us. Two isolated metallic solid spheres, one is capital R and the other one is 2R, are charged such that both have same charge density sigma. Both have same charge density sigma. What is the charge density? Charge density is nothing but charge per unit area. Charge per unit area. Okay. The spheres are then connected by a thin conducting wire. Connected by a thin conducting wire. If the new charge density of the bigger sphere is sigma dash, they are asking what is the new charge density of the bigger sphere. Bigger sphere is sigma dash, then the sigma dash by sigma is. Okay. So how can we simplify? How can we approach this? First of all, let us understand the first case. Let us say there are two spheres. One is having the radius r and the other one is having the radius capital 2r. 2r. Therefore, what is the charge on the first one? We can say charge is always be written as charge density into area. Charge density into area. That is 4 pi r square, and Q2 can be written as sigma into 4 pi into 2r whole square. So what is the answer we're getting here? We can say sigma into 16 pi r square. We will get it 16 pi r square. Therefore, what is the total charge we can say? We can say it is Q1 plus Q2. Q1 plus Q2. So whenever we add, we will get it as nearly 16 plus 4, 20 here. So 20 pi r square into sigma. 20 pi r square into sigma. Okay, na? So this is the total charge on the system of two spheres. So later, second case, what they are saying as here, second case, these two spheres are joined. These two spheres are joined by a wire, metallic wire. What happens means whenever the two spheres of different radii and different charges are joined together, are placed in contact, they share their charges. They share their charges up until the potential of both the spheres will become equal. Therefore, you can say that what is the new charge? What is the new charge? Let us say Q1 dash can be written as Q into R1 divided by, we can say R1 plus R2. And similarly, Q2 dash will become equals to Q into R2 divided by R1 plus R2. This is a shortcut formula you can remember. And in the question they are saying, and they are talking only about bigger sphere, that is Q2 dash. So let us calculate what is the Q2 dash here. How much you will get it? So Q2 dash will become equals to, what is the capital Q value here? Capital Q is equals to 20 pi r square. 20 pi r square into sigma into 2r divided by r plus 2r here. So Q2 dash becomes equals to 20 pi r square sigma into 2r divided by 3 into capital R. We will get it here. So R will get cancelled. Then we will be remaining with 40 by 3 into pi r square into sigma. 40 by 3 into pi r square into sigma. Therefore, what is the new surface charge density of the bigger sphere? Sigma 2 dash is equals to, we can say that 4 pi into 2r whole square. So just substitute what is the q2 dash my value here, 40 by 3 into pi into r square into sigma divided by, we can say 16 pi r square, you will get it 16 into pi r square, 16 into pi r square. So just do calculation, we'll get the answer pi r square also get cancelled. They're asking value, what is the value of sigma dash by sigma dash, there are sigma dash, sigma dash by sigma will become equals to, we can say 40 divided by 48, 40 divided by 48. We can say 8 5s are 40, 8 6 are 48. So we'll get the answer as how much here? 5 by 6, 5 by 6. Is it clear? So like that we can go with option C as a right answer. Option C a right answer. Please go through the solution once again. So please concentrate and listen. Definitely we can get it and utilize this shortcut formula. It helps you in the future also. Okay. Now let us move on to the next question. What they have given to you. Given below are the two is a statement. Statement one is labeled as assertion and the other one is labeled as a reason here. Okay, let us read assertion and reason here. What is the assertion they have given? If an electric dipole of moment, what is the moment they have given 30 into 10 power minus 5 coulomb meter is enclosed by a closed surface, the net flux coming out of the surface will be 0. Is it right or not Flux is always equals to charge divided by epsilon naught. What is the charge here? Plus 2 microcoulomb. Dipole moment they have given dipole moment is given as, okay, anyway we can say that flux is equals to net, we can say plus q and minus q divided by epsilon naught. The flux due to a dipole always equal to 0, because we can say that in a dipole there are two equal and opposite charges. Hence we can say that is the thing. What is the reason they have given? Electric dipole consists of two equal and opposite charges. Yes, because of this reason only the flux due to dipole is always be equal to 0. Hence we can say that both are correct, and reason is the correct explanation of A, that is option C. We will get it option C will get it. Okay. Now let us move on to the next question. What they have given to us. Please read this here. A large plane sheet of charge having surface charge density here sigma. What is the surface charge density they have given 15 into 10 to the power of minus 16. We will get it 15 into 10 to the power of minus 16 coulomb per meter square lies in the xy plane. The electric flux through a circular area of radius. What is the radius of the circular area they have given 0.4 meter they have given is, if the normal to the circular area makes an angle 60 degree with the z-axis. Okay. First of all, I will draw the figure, then we will get a clear picture about this here. So let us say what they are saying here. There is a large plane sheet. Which is placed in the xy plane. So at some point, let us say here, there is a circular area, and its normal is making an angle, 60 degree with the z-axis. Whenever we consider a charged sheet, we can say that the field is directed as shown in the figure. Therefore, what is the flux? We can say here flux is equals to EA into cos theta. Therefore, flux is equals to what is the electric field E electric field. We have to calculate that, because since it is a large plane sheet, we can say it is sigma by 2 epsilon naught into area is pi r square into cos theta is equals to 16 degree. Normal always represents the area vector only. Area vector is always represented by the normal. Anyway, both are one and the same only. So now substitute the values, you will get the answer. What is sigma? They have given 15 into 10 to the power of minus 16 divided by 2 into 8.854 into 10 to the power of minus 12 into pi is 3.14 into r square. R square is 0.4 into 0.4, which is nothing but 0.16 into 1 by 2. 1 by 2. Okay. So just do calculation here. Definitely you'll get the answer. 2 0.08 you will get it 0.08. So how much you'll get it approximately? You can say 15 into 3, 45. 45 into 8 into 10 to the power of minus 2 into 10 to the power of minus 16 divided by 2 into 9, 18 into 10 to the power of minus 12. We'll get it. We'll get it. So just do calculation properly, then we'll get the answer. Then we'll get the answer as nearly ಎಷ್ಟು ಬರಬಹುದು ಇದು ಅಂತ ಒಂದ್ಸರಿ ನೋಡಿ ನಿಮಗೆ ಒಂದು ಐಡಿಯಾ ಸಿಗುತ್ತೆ. ಇಸ್ ಇಟ್ ರೈಟ್ ಆರ್ ನಾಟ್ ಮಾ? ಸೊ ವೆನೆವರ್ ವಿ ಡೂ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಹಿಯರ್ ವಿಲ್ ಗೆಟ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 0.209 into 10 to the power of minus 16 plus 12 will get it ma. So you should get the answer as 2.1 into 10 to the power of 2.1 into 10 to the power of minus 3 we should get it. Minus 3 na illa minus 5 ಬರಬೇಕಪ್ಪ ಸಾರಿ. 2 point calculate ಮಾಡಿ ನಿಮಗೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ 10 to the power of minus 5. Okay, I'll rewrite this ma 10 to the power of minus 5 you will get it. That is a flux. That is a flux ma. So what is option we can say ma here? 2.1 in the sense we can go with option D as a right answer. Option D is the right answer. I hope you got the answer ma clearly. Now let us move on to the next question. What they have given to you? What they have given to you? Please read it ma here. Electrical as well as gravitational effects can be thought to be caused by the fields. Caused by the field. Which of the following is true? Which of the following is true for electrical or gravitational field? That means we have to remember the properties of the electric field and gravitational field to answer this question. I have already explained the properties of the electric field and gravitational field in the respective chapters. So see, the field concept is often used to describe the contact forces. Contact forces will not, we cannot be described by the field. Gravitational electric does not always exist in the space around an object. So whenever there is an object of mass m, definitely there will be a gravitational field. Whenever there is a particle having a charge, then definitely there will be electric field. So this is also wrong here. Fields are useful for understanding the forces acting through a distance. Yes, we can apply because we can say that, observe this, gravitational force is also inversely proportional to r square and electric field force is also inversely proportional to r square. That means it is used to understand how the field varies as we move away from the particle or a charge. There is no way to verify the existence of the force field since it is just a concept. This is also wrong. There is a theory, there is a field theory. So we are, by with the help of which we can explain all those things. Hence, we can say option C is the correct statement. Correct statement related to electric and gravitational fields. Okay. Now, like that, we have to think. Let us move on to the next question. What they are saying to us. Observe this. 10 power 9 electrons move out of a body to another body every second. Okay. Then the time required to get a total charge of 1 coulomb on the other body is. So observe this. We can say that for 1 second. Otherwise, we can say that they're asking the time, they're asking the time. See here, for 10 to the power of 9 electrons. For 10 to the power of 9 electron, that is, we can say that the charge is equals to 1.6 into 10 to the power of minus 19 into 10 power 9, which is nothing but 1.6 into 10 to the power of minus 10 coulomb. 10 coulomb, it require only 1 second. Therefore, we can say that for 1 coulomb, for 1 coulomb, what is the time required here? What is the time required? Time t is equals to 1 divided by 1.6 into 10 to the power of minus 10. If you do simplification, remember that 1 divided by 1.6 is a constant value and is always be equals to 0.625 into 10 to the power of plus 10. We will get it. Therefore, what is the time? Therefore, time t is equals to 6.25 into 10 to the power of 9 seconds. We will get it. But in the option they have given the years. Therefore, see here time t is equals to 6.25 into 10 to the power of 9 divided by 365 days into 24 hours into 60 into 60. If you do this, then definitely you will get the answer as approximately or nearly or exactly 198 years. You will get it. But you have to do calculation. There is no other way. There is no other way. Hence, we can go with option C as a right answer. Option C, right answer. I hope you got the answer. Let us move on to the next question. What they are saying to us. See here. A circular plane sheet of radius 10 centimeter. 10 centimeter. R is equals to 10 centimeter. Is placed uniform electric field. What is electric field? They have given 5 into 10 to the power of 5 Newton per coulomb, making an angle 60 degree with the field. So theta is equals to 60 degree with the field. Then they're asking what is the electric flux through the sheet. Many people will go confusion whenever we read this question. Oh, this much only. No, happily we can apply the flux formula and we can get it. But what they are saying to us, we have to understand. Let us say there is a uniform electric field. There is uniform electric field. So please make sure about this here. And there is a circular coil. There is circular coil. And this coil is making an angle with see here, observe this here. This is the electric field. And the plane of the coil is making an angle 60 degree. Plane of the coil is making an angle 60 degree. That is the meaning of the question here. Therefore, what will be the area vector here? Area vector will make an angle 30 degree. Will make an angle 30 degree. Will make an angle 30 degree with the field. Is it right? That is what we have to calculate. We have to calculate. Because whenever we use flux is equals to E into A into cos theta. Here we have to go with the theta dash, which is nothing but EA into cos of 90 minus 60. So just substitute all the values here. 5 into 10 to the power of 5. Area is pi into r square. What is the radius? 10 centimeter. No, so 10 into 10 to the power of minus 4 into cos 30. Cos 30 is how much here? Root 3 by 2. Cos 30 is equals to root 3 by 2. Is it right or not? Hence, just multiply everything. You will get the answer here. Cos 30. Cos 30 is root 3 by 2. So if you do simplification here, 5 into 3, 15 approximately into 10 to the power of 5 plus 2, 7. 7 minus 4, it is 3 here. Into root 3 is 1.732 divided by 2. Divided by 2. So whenever we do with the simplification here, you will get 15 in the sense we can go with 17.5. Approximately 17.5. So if you do multiplication, you will get nearly, we can say that 136 something, you will get it. Otherwise, 13.6 something, you will get it. 13.6. Is it right, 13.6. How can you get it, here? 13.6 will not get it. So, but whenever we multiply this value, so please go through it once again. Go through the calculation once again. Whenever you observe this, I made a mistake here. Calculation ಗೊತ್ತಾಗಿದೆ ನಮಗೆ ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ. You will get 7.5. Then you will get approximately you can say it is some 13.6 something. You will get it 13.6 into 10 to the power of 3, which is nothing but 1.36 into, if you go for exact calculation, then you will get the answer here. 1.36 into 10 to the power of 4. Newton meter square per coulomb. That is the option B as a right answer. Option B is the right answer. Okay. So like that we have to understand the next problem also. Please go through it here. A charge capital Q is to be divided on two objects. The values of the charges on the objects so that the force between the two objects can be maximum. They're asking very simple. So actually this is a shortcut and direct formula here. We can say Q1 is equals to, we can say let us say it is a Q, small q we can denote, and Q2 becomes equals to capital Q minus small q. Therefore, what is the force between them here? K into, we can say Q1 Q2 divided by R square. For force to be maximum, for F to be maximum, we can say that if I differentiate with respect to small q, it must be equal to 0. So whenever we differentiate this small q here, we'll get capital Q into q minus q square, we'll get it might is equal to 0. So whenever we do this simplification, we will get the answer as nearly, see here, capital Q minus 2q will become equal to 0, or small q becomes equals to q by 2, q by 2. Therefore, what is the option? We will get it here, q by 2, comma q by 2. Hence, option C is the right answer. Or you can remember it as a direct formula, direct also, no need, no issue in that. So let us see the next question what they have given to you. Two large thin metal plates are parallel and close to each other. On their inner faces, the plates have the surface charge densities of opposite signs and of magnitude 16 into 10 power minus 22 coulomb per meter square. The electric field between the plates is, observe this, there are two large parallel plates as shown like this here. One is having the plus sigma and the other one is having the minus sigma. Is it right? And they are asking us to calculate what is the electric field. What is electric field in between the plate? Let us consider any one point P here. The field due to positive is E plus and the field due to negative is E minus. Is it right? Therefore, the net field is always equals to E due to positive plate and E due to negative plate. So just substitute all the values here. We can say sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is nothing but sigma by epsilon naught. So just substitute all the values, you will get the answer. Electric field is equals to, what is sigma? They have given 16 into 10 to the power of minus 22 divided by, what is epsilon naught value here? 8.854 into 10 to the power of minus 12 here. So we can say 16 into 10 power minus 22 divided by 9 into 10 to the power of minus 12. So whenever we do this, we can say 1 point nearly ಎಷ್ಟು 7 ಅಂತಂದಾಗ you can say 1.6 something, you will get it here approximately. We can say 1.6, we can say 1.6 into 10 to the power of minus 10, we will get it. So this is the electric field, this is electric field. 1.6 into 10 to the power of minus 10, you can say Newton per coulomb. So what is the option we can get it? We can go with the option C as a right answer. Option C a right answer. Is it clear? Now similarly, let us move on to the next question. What they are saying to us: a point charge 4 microcoulomb is at the center of a cubic Gaussian surface 10 centimeter on edge. So let us say there is a cubic surface, or there is a cube here like this. There is a cube and there is a charge at the center. The net electric flux through the surface is, net electric flux always be equals to, see here, the flux does not depend on the shape of the Gaussian surface. Therefore, we can say Q divided by epsilon naught. What is the Q they have given? Q is equals to 4 into 10 to the power of minus 6 divided by epsilon naught is 8.854 into 10 to the power of minus 12 here. So 5 becomes equals to, we can say 40 into 10 to the power of minus 7 plus 12, approximately 9 in the denominator. So we can go with approximately 4.4 something, we will get it. 4.4 into 10 to the power of 5, 10 to the power of 5. So what is the option we can say here? We can go with option C is the nearest answer. Option C is the nearest answer. Okay. Now similarly, Let us move on to the next question. What they have given to you? I think you can easily answer this question. Two infinite plane parallel sheets separated by a distance d have equal and opposite charges. Charge densities. One is having the positive charge and the other one is having the negative charge. One is having the positive charge and the other one is having the negative charge. Therefore, we can say that at some point, see here the field due to positive plate is E plus and the field due to negative plate is E minus. Therefore, we can say that the net field is always be equals to E due to positive and E due to negative, which is nothing but sigma by 2 epsilon naught plus sigma by 2 epsilon naught. You will get the answer as sigma by epsilon naught. Is it right, ma? Hence, we can go with option B as a right answer, ma. Option B is the right answer. Already we have explained to you, ma. Okay, let us move on to the next question. What they are saying to us: the electric field due to a uniformly positively charged hemisphere at a point on a diameter away from the center is directed. From the center is directed. Okay. So what they're saying, ma, charged hemisphere. They are saying, let us consider there is a hemisphere. Let us say this is a hemisphere, and this is a diameter. This is a diameter, and they are asking. They are not asking the magnitude of the electric field, just they are asking what is the direction of the electric field. Perpendicular to diameter, parallel to the diameter, at an angle tilted towards the diameter, at an angle tilted away from the diameter. They are asking here. So let us say this has given a charge. This has given a charge here. So observe this. Whenever we consider a small element in the upper side having the charge dq, let us observe this. This charge will produce a field like this. So whenever we solve into two components, one is along the x component and the other one is along y component. In the same manner, if I imagine a small element like this here, dq, then it will produce the electric field as shown. So one is along the x and the other one is along the y. Is it right or not, ma? Therefore, we can say that y component of electric field, y component of electric field will cancel each other. Therefore, the net electric field is always be equal to summation of the electric field along the x direction and the x direction. That is, we can say that the electric field is always perpendicular to the diameter. Is it right or not, ma? So like that we have to think and we have to analyze the numerical question. Is it clear? Now let us move on to what is the option, ma? Now perpendicular to the diameter. Hence we can say option A is the right answer. Option A is the right answer. Okay. Now let us move on to the next question. What they are saying to us. Please think about this. A thick metallic spherical shell of inner radius R1 and outer radius R2. Has a charge plus Q. A charge small plus Q is placed at the center per unit area on the outer surface is. They're asking what is the charge plus Q is placed at the center and what is the charge per unit area. That is, we have to calculate what is the sigma on the outer surface. Okay. So how can you do this? Observe this. One thing it should be very clear, Initially, the outer surface is having a charge plus Q. And at the center I am placing a charge of plus small q. So since it is a metallic sphere, because of the induction, the inner will have a charge that is minus q. The outer surface will have a charge plus q because of induction. Therefore, what is the on the outer surface, what is the total charge, on the outer surface? The total charge is equals to capital Q plus small q, capital Q plus a small q. Therefore, what is the charge here? Charge is nothing but, sorry, charge density is equals to charge by area. You have to calculate only outer surface area, that is nothing but, you can say capital Q, Q total here, capital Q plus small q, divided by 4 pi R2 square. Capital Q plus small q divided by 4 pi R2 square. Hence, we can select option C as a right answer. Option C right answer. I hope you got the answer clearly. Similarly, let us see the next question what they have given to you carefully. Sir, two particles of charges q1 is equals to plus 8q and q2 is equals to minus 2q are placed as shown in the figure. Let us say this is a q1 and this is a q2. They are separated at a distance of capital L here. So observe this. What is charge q1? q1 is equals to plus 8q and the charge q2 is equals to minus 2q here. Is it right? Can a proton be placed so that we can say at what point away from the q2 away anta ಹೇಳ್ತಿದ್ದಾರೆ. Why they have mentioning away means, see here, in between proton. What is a proton here? Proton charge is always be equals to plus e. Is it right? One is positive charge and the other one is negative charge. If you place a proton in between, the net force cannot be equal to zero. Therefore, directly they are saying that at what point we have to place a proton, on the x-axis, so that the proton will be in equilibrium. We don't know the distance. Let us call it as x. Let us call it as a x. So observe this here. Because of this positive charge, it will experience a force like this. Because of negative charge, it experiences a force in opposite direction F2. Therefore, we can say at some point the net force may become equal to 0. Okay. And so see here, for equilibrium, we can say that the force due to 1 must become equals to force due to 2. You can say k into q1 into qp divided by x square, k into q2 into what is the qp divided by what is the value of this distance here. So whenever you observe this distance will become equals to, we can say x minus l, l. Therefore, x minus l whole square. Is it right? So just substitute everything here. K will get cancelled. Substitute qp will also get cancelled because both are proton only. What is the q1 value? q1 is equals to 8 and qt is 2. 8 divided by x square is equals to 2 divided by x minus l whole square. 2 1 2 4 here. So just do cross multiplication. You will get it as 4 into x square plus l square minus 2 into x into l will become equals to x square here. So whenever we multiply and divide 4x square plus 4l square minus 8xl is equals to x square. So take this x square to left hand side and simplify. Then you will get the answer as nearly. Please do this here. So finally you will get it as 3x square minus 8x into L plus 4L square must be equal to 0. Okay. So whenever we do simplification by using x is equals to minus b plus or minus root of b square minus 4ac divided by 2a. This is the formula for calculating the root. Then we will get x will become equals to 2l, or x will become equals to 2 by 3l. 2 by 3l is not possible. Hence we can go with x is equals to plus 2l. X is equals to 2l. Is it right? 2 by 3 in the sense it will come in between the two charges, which is not possible. Therefore, we can go with option A as a right answer. So please solve this calculation here. So what is this A? B is nothing but 8L. If you want, I can write here B. B is nothing but 8L. We'll say minus 8L, and A is equals to 3 and C is equals to 4L square. If we do it by substituting, then we will get it. Now let us move on to the next question. What they are saying to us. A thin glass rod is bent into a semicircle, is bent into a semicircle of radius capital R, a charge capital Q is uniformly distributed along the upper half, and a charge minus capital Q is uniformly distributed along the lower half. Okay. The magnitude of the electric field at the center of the semicircle is, we have to calculate the magnitude at the center of the semicircle. So what is the situation they have given here? So please observe this. Actually, there is a thin rod, a straight rod. It is bent in the form of a semicircle. It is bent in the form of semicircle. The upper half is given a positive charge, upper half positive charge, and lower half is given a negative charge. Okay. So see here, this is the diameter. Whenever we consider a positive charge in the upper side here, the field at the center will be as shown like this here. So it can be resolved into two components. One is along the x and the other one is along the ey. And similarly, whenever we consider lower half, since the negative charge, please make sure about this here. The negative charge, the field is directed as shown like this. Field directed as shown in like this. So we can resolve it in two components. One is E along X, another one is E along Y. Is it right? Therefore, from the figure, we can say that the electric field at the point P is always equals to Ey plus Ey. That is only due to y components. Okay, if we go with integration technique and everything, we will get the answer as lambda divided by 2 pi epsilon naught into what is the radius, small r or capital R. They have given capital R. We will get it. Because initially it is straight rod, it is bent in the form of a semicircle. But what is the lambda value we can say here? But lambda will become equals to charge divided by circle, that is the pi r. So just substitute, you will get the answer here. Therefore, the field at the point P will become equals to Q divided by pi r into, you can say, 2 pi epsilon naught into capital R. We will get it. Pi r into 2 pi into epsilon naught into capital R. So whenever we do calculation here, pi r, is it right here? Pi r in the sense, and since we are calculating only half of that we're getting only half of that, then we can go with pi r by 2 here, pi r by 2. We cannot take, we will take only quarter of the circle. Therefore, we can go with only, what is it here? Pi r by 2. Then we will get 2q by lambda becomes equals to 2q divided by pi r. We will get it. So whenever we substitute this value here, then we will get the answer as, observe this, E at the point P is equals to 2 will get cancel, q divided by pi square epsilon naught into r square. We will get it. Q divided by pi square epsilon naught into r square. Let me check whether the option is there or not. Q divided by pi square epsilon naught into r square. Hence, we can go with option B as a right answer. Option B as right answer. I hope you got the answer clearly. Understood now why we are taking only pi r by 2 means we are calculating only for quarter of a circle. Okay. Now let us move on to the next question. What they are saying to us. The electric field in a region is given by, what is the electric field they have given here? A divided by x cube into I cap plus b y into j cap plus c z square into k cap. We can say the SI units of A, B and C are respectively. Okay. So how can you simplify here? So observe this. What is electric field? We can say Ex into I cap plus Ey into j cap plus Ez into k cap will become equals to A by x cube into I cap plus by into j cap plus cz square z square into k cap. So just equate it here. This implies a divided by x cube will become equals to ex, or a becomes equals to ex into x cube. So what is this ex? Nothing but electric field only, no. Therefore we can say that Newton per coulomb into meter cube, you will get it. And similarly, what is the by? By is equals to ey here. Therefore b becomes equals to ey by y, ey divided by y. We can say that is Newton per coulomb per meter. That is nothing but Newton per coulomb per meter. We will get it. So what is the third quantity? We can say c into z square is equals to ez, which implies c is equals to ez divided by z square. Ez is Newton per coulomb divided by z square is also meter square. That means Newton per coulomb per meter square. We will get it. So whenever we go with the options carefully, then we can say Newton meter cube per coulomb is option. What is the option we can say here? Newton per coulomb, volt per meter, everything they have mentioned. Everything they have mentioned. So please think about this. Definitely you'll get the answer. We can say that volt per meter square. Volt per meter square. We can also write. Observe this. Newton per coulomb is the electric field, no electric field. If I multiply and divide it by my meter and divided by meter, then observe this, Newton per coulomb into meter will give you what is the potential difference. Potential difference, which is nothing but volt per meter square. Sorry, volt per meter square will get it. In the same manner, Newton meter square. So we can go with option A as a right answer. Here option is right answer. I hope you got it, Noma. How can you simplify this? Now let's go to the next question. What they have given to you. So an oil drop of n excess electrons is held stationary under a constant electric field E in Millikan's oil drop experiment. In Millikan's oil drop experiment. The density of the oil is rho. Density of the oil is rho. Then they're asking what is the radius of the drop. Radius of the drop. So whatever may be the experiment, say here held stationary, indicate that we can say that m into g, that is weight of the drop, must balance the force due to electric field. Okay. So see here m into g is equals to E into what is this value here? Q is nothing but n into small e, So what is m? Mass can be as 4 by 3 pi r cube into rho into g is equals to what is the value? E into capital N into E. I want R. I want only R here. So R cube becomes equals to, we can say that 3N E into capital E divided by 4 pi rho into G. So R becomes equals to, we can say that 3N E into capital E divided by 4 pi rho into G whole to the power of 1 by 3. We will get it. 3 Ne into capital E in whole power 1 by 3. You should get it. Is it right? 3 Ne capital E divided by 4 pi rho G whole power 1 by 3. In the sense, we can go with option C as a right answer. Option C as a right answer. I hope it is clear. Like this, we have to think and we have to analyze all the problems from the chapter electric charges and fields. Okay. With this, the problems which are given in our classroom discussion has been completed. If you have any doubt, you please go through the video once again. Please concentrate and listen. Definitely you'll get a clear picture how we have applied the formula, formulas and all those things. Okay. With this, I am going to end the session. We'll meet you in the next video. Until then, please keep revising. Don't waste the time. Okay. Thank you very much.